Good morning, everybody. I hope you had a nice weekend. And we are continuing on with our operations of radicals. Also, just wanted to mention again that if you are wanting to set up something online, like a Google Hangout, and go over anything, please don't hesitate to ask me, and we can surely set that up. So, I do have a couple students that are doing that today. So, if you'd like to take advantage of that, please let me know. So once again, we are looking at the nth root of a. So that n, the n part again is called the index. And the a part of that is called the radicand. Now, in addition and subtraction, you have to have what are called like radicals. And it's just like having like terms. So what that means is that if you're going to be able to add and subtract radicals together, both the index and the radicand have to be exactly the same. All right, so we're going to treat these just like we would when we were adding and subtracting like terms. So in an example, if you had 3x squared plus 5x squared minus 2x, what can we add together? Well, we can add together the coefficient of the x squareds because those x squareds are like terms. I may not add together this 2x with anything because it is not a like term. So if I were simplifying this, this becomes 8x squared minus 2x. So only the coefficients of the like radicals need to be added or subtracted together. The radicand itself stays the same. All right, so we're starting off with some basic ones here. So these have the index of 2, radicand of 6. Those are alike. Therefore, we can add together this 5, well, subtract, I guess. We can subtract the 5 and the 3. So what's 5 minus 3? 2. We do not change that radicand or the index, so that answer is 2 square root 6. All right, so in this problem, what's alike? The 5, the root 5, the root 5, the root 7, the root 7. So I have to add together those coefficients. All right, so the square root of 5 is going to go with the square root of 5, so I have a 12 minus 2, so that's 10 square root 5. And the square root 7 goes with the square root 7, so I have a positive 6 with a positive 8. So that's going to give me a positive 14 square root 7. All right, and that is your answer. You cannot do anything else with that problem. 10 square root 5 plus 14 square root 7. That's it. You are done. All right, looking at this. Now, I do have a radicand that's the same. Okay, yes, these are the same, but the indexes are different. So you're only able to simplify the same index with the same radicand. All right, now that means that I can take, this is like a 1 cube root of 4 minus 8 cube root of 4. That gives me a negative 7 cube root of 4 plus 5 square root 4. Now, actually that 5 square root 4, I can simplify that square root of 4. I may not simplify the square root of 3 because there's not a cube root that comes out of that, just a 2 and a 2. So this gives me a negative 7 cube root of 4 plus, well, this is the same thing as 5 times 2, so that's my answer. Negative 7 cube root of 4 plus 10. All right, well, what if they don't have the same radicand? All right, so what we're looking at in cases that the radical can be reduced, you're going to have to do that first. Okay, I wish it was easy as just saying you could take the 2 plus the 10 and then the 45 plus the 20. Okay, that's not how it works though, guys. Not how it works. You're going to have to reduce these first. So 45, that's the same thing as 5 times 9, which is 3 times 3. So a 3 is going to come out, the 5 stays in. 20, that's 4 times 5, 2 times 2. So a 2 comes out and the 5 stays in. So this is going to give me 6 square root of 5 plus 20 square root of 5. And now that these are the same, we may simplify this to give us our solution of 26 square root of 5. Do the same thing again. Let's reduce this 98. So that's going to be 2 times 49, which is 7 times 7. So the 7 comes out. So this is 3 times 7, square root of 2. I have 2 times 16, 2 times 8, 2 times 4, 2 times 2. So 1 2 comes out, 2 2's come out. That's a total of 4. All right, so that's going to give me, the 2 is already there. This 2 and this 2 gives me a total of 4. This one stays in, so that's square root of 2. 18, that's 2 times 9, which is 3 times 3. So I'm going to get a positive 8 times 3, square root of 2. All right, so these are all the same, which means after I simplify those values, 21 square root 2, 8 square root 2, 24 square root 2, gives me a grand total of 21 plus 8 plus 24. So I have 53 square root of 2. And that is the answer. Okay, a couple more examples, and then we are done for the day. So I'm just changing it up with cube roots. Again, same rules are going to apply. We have to have a like radical, so we're going to need to break down. Now I'm looking for perfect cubed numbers. So that's going to give me 2 times 24, 2 times 12, 2 times 6, 2 times 3. So what's going to come out? I need 3 of those, so a 2 comes out, and the cube root of 6 stays in. All right, 162, that's going to be 2 times 81, 3 times 27, 3 times 9, 3 times 3. All right, so I need 3 of these to come out, to be able to come out, and that gives me plus 3 cube root of 6. All right, radical is the same. This answer is 5 cube root 6. All right, last one. I have 2 times 125, 5 times, for some reason 5 times 25. I don't know why I was blanking there for a minute. 5 times 5. All right, a 5 comes out, the 2 stays in, so that's 5 cube root of 2, plus, do this again, so I get 2 times 64, 2 times 32, 2 times 16, this one's going to take a while, 2 times 8, 2 times 4, 2 times 2. All right, there's 1 2 that can come out. There's another 2 that's going to come out. That 2 stays in. So a 2 comes out, a 2 comes out. What's a 2 times a 2? A 4 cube root 2. So my answer, 9 cube root 2. Okay, so next thing item up for business is for you to do the assignment and make sure you get that turned in. Alrighty, and I will talk to you guys tomorrow.